Welcome to this episode in the 3D visualization series of tutorials and guides in an ongoing 3D Technologies program. I'm your host, Aaron Ellis. In this video, we will discuss what 3D visualization is, discover what it is used for, introduce some software tools, and then learn how to use one of those programs to move around in 3D space. With all of that out of the way, let's get started. 3D visualization is the digital display of virtual spatial objects, environments, and information. 3D visualization can be used for tasks as simple as showing sales figures for presentations or titling for broadcast television. Or it can be put to work on advanced tasks like video game development or feature film production. At its heart, 3D visualization works by calculating the way simulated lights interact with the virtual structural geometry of digital objects like squid, ships, and satellites. If all of that sounds fake, that's because it is. All 3D visualization, from the simplest to the most complex, is an illusion trapped inside a computer's screen. The process of displaying these simulations is called rendering. There are three major elements of rendering, but we will only focus on two of these: real-time rendering and ray-traced rendering. Real-time rendering is constant 3D scene display. In real-time rendering, there are no delays for lighting calculation or special effects. With this method, the scene elements are drawn and redrawn many times per second. In order to permit user interactivity, this rendering method sacrifices visual quality for speed. As computers get more powerful, the image quality improves without slowing down the display. The most familiar example of real-time rendering might be the worlds and characters in modern 3D video games. There are three important styles of real-time rendering. Wireframe rendering draws scene elements with only lines. It is simple and quick, but offers no shading and no surfacing. Phong rendering draws solid objects with fixed lighting. It is simple and quick, but provides only basic shading and surfacing. PBR, or physically based rendering, attempts to display photorealistic scenes. This modern approach is advanced and quick, while providing approximated yet still believable shading and surfacing. The primary alternative to real-time rendering is ray-traced rendering. Ray tracing is the delayed display of 3D scenes. It attempts to calculate the physics math of light bouncing around a scene full of objects with varying material properties. Those simulated materials can absorb light, reflect it in predictable patterns, or scatter that light haphazardly. More lights and more geometry and more surface materials means more calculation time. Ray-traced rendering can take from many seconds to many hours to draw just one frame, or one image. Typical film or television productions require 24 to 30 frames per second for visual effects. There are many different ray tracing renderers on the market today. Some are more accurate or realistic than others. Some handle grass or smoke better. Some calculate images faster than others, and some are expensive, while others are free. For the purposes of this lesson, we will only focus on real-time rendering with wireframe, Phong, and PBR rendering. Depending on your computer system, wireframe and Phong might offer the smoothest working experiences. There are perhaps hundreds of 3D visualization programs in existence. Many of these are expensive, but some are free. This software internalizes all of the math required to keep track of thousands of virtual objects and calculates their structural geometries in virtual space on an animated timeline. Here are just a few 3D visualization programs. Autodesk Maya has been used in the development of thousands of films, shows, and games, so many, in fact, that I won't even attempt to list them here. Maya is licensed on an annual subscription model and costs about $1,600 per year. The Foundry's Modo has been used on blockbuster feature films like Ant-Man and also some video games. Modo is licensed on a one-time licensing model and costs around $1,900 for the current version. And finally, we have Blender 3D. Blender has been used in various aspects of film development for Wonder Woman and recent Star Wars movies. It has also been used in the Walking Dead television series and in recent Oscar and Emmy award show broadcasts. Blender is powerful, full-featured, fast, and free. Thanks to the nonprofit Blender Foundation and donations from individuals and corporations, Blender will continue to cost $0 forever. We will be using Blender since it is the most accessible of the available options. While other 3D development tools might be used more often in the U.S. entertainment industry, Blender is used by tens of thousands of professionals around the world in a variety of industries. Unfortunately, powerful 3D programs like Maya, Modo, and Blender are not especially easy to learn. However, if we start with the basics and master movement within our program of choice, then all future Blender skills will become much easier to attain. Whether it's learning to use a microwave oven or how to drive a car, one of the first steps to success in acquiring any new technology skill is discovering where all of the controls are, how they work, and what each does. Blender has a lot of controls to figure out, but fortunately, some of these are similar to other computer programs you might have used before. Also, there are additional features like interface persistence, text panels, and integrated help search tools that make it easier to pass knowledge from one Blender user to another. When starting Blender for the first time, you may be presented with a splash screen asking which mouse button you wish to select objects with and what action should occur when you press the spacebar on your computer's keyboard. The default options of left-click select and spacebar play should work fine. Blender has a lot of controls, but for this lesson, we will only focus on the most important ones for navigating in 3D space. Future videos will highlight additional controls for setting up scenes and rendering animations. The main elements of the Blender interface are the menu bar, the 3D viewport, the outliner, the Properties panel, the timeline, the status bar, the toolbar, the sidebar, the render modes buttons, the orbit widget, and the zoom, pan, camera, and perspective buttons. The menu options in Blender are similar to those in many other software packages. But because Blender is so powerful and so wide-reaching, it has a number of additional options. For example, instead of creating just a new blank 3D scene, new Blender projects can also focus on 2D animation, 3D sculpting, visual effects, and even video editing. Traditional menu options include opening Blender files, saving current projects, and importing files from external 3D programs. One of the most important skills for us to learn is how to maneuver in 3D space. And a big part of that is being able to orbit the 3D viewport around a project's scene. There are a number of ways we can do that, but one of the easiest is to use the orbiting widget in the upper right-hand corner of the 3D viewport. By left-clicking and dragging inside the orbiting widget, we can orbit around or rotate around the objects in our scene. By left-clicking the colored dots inside the orbit widget, we are able to switch from free perspective views to locked orthographic left, right, up, down, front, and back views. In Blender, orbiting a scene can also be accomplished by pressing and holding the middle mouse wheel and dragging the mouse. Locked orthographic viewpoints can also be accomplished by pressing various number keys on a numeric keypad on an extended keyboard. Unfortunately, most laptop computers do not have an extended numeric keypad. Another important viewport option is the ability to zoom in and out within our scene. This can be accomplished within the interface by using the Zoom or magnifying glass button. By left-clicking the zoom icon and moving our mouse, we can zoom in and out of our scene. Zooming can also be accomplished by rolling the mouse wheel forward and backward. Another important viewport option is the ability to pan or move the viewport left, right, up, and down. This can be accomplished by left-clicking the hand or the pan icon and then moving the mouse. Panning can also be accomplished by holding down the Shift key on your keyboard and pressing and holding the middle mouse wheel while moving the mouse. Sometimes it's important to switch from the traditional 3D viewport into the camera view. These viewport changes can be toggled by left-clicking the camera icon. Switching between the camera and the viewport can also be accomplished by pressing the 0 key on a numeric extended keypad. We can also switch from perspective to orthographic views. Most of the time, we'll probably remain in perspective mode. Now that we've learned how to navigate in 3D space, let's take a look at how we can change render modes in Blender. By default, Blender starts off in solid or Phong rendering mode. But wireframe rendering is also very useful, especially when some objects are hidden behind or within other objects. After wireframe is solid rendering. Next is the material preview render mode. Sometimes it's called look dev. And finally, we have our rendered view. By default, Blender 2.83 uses PBR as its primary rendering method. Ray-traced rendering with Cycles or Octane or Lux Render are also possible, but that's beyond the scope of this lesson. Within the options of each of these default render modes, there are additional options and capabilities available. There are several other methods for manipulating the 3D viewport in Blender. Some of them are glorious, and if that sounds like an overstatement, it's not. Flying around in a Blender scene is a liberating experience, but unfortunately, that is beyond the scope of this lesson. Once we've gotten the hang of moving around in 3D space, let's take a look at some of the other options available to us, specifically the toolbar. The toolbar is located on the left-hand side of our 3D viewport. It can be expanded, retracted, or resized with various left-click operations from our mouse. In addition, it can be hidden or shown by toggling the T key on our keyboards. The toolbox is where we can find our settings for select mode, cursor placement, move, rotate, scale, and multi-transform options. Additional tools like annotation and measuring are beyond the scope of this lesson and won't be covered here. The sidebar panel can usually be found on the right-hand side of our 3D viewport. However, most of the time, it is hidden by default. We can expand that using a left click of our mouse button, or we can toggle between revealing and hiding the sidebar using our N key on the keyboard. The sidebar includes many different features. Some of these additional features are located on a tabbed strip to the right of the sidebar. That's it for this lesson. While the activities for this video are very simple, they are important in preparing us for the next step, which will include setting up 3D scenes with objects, lights, and materials. Have fun with this first part of our 3D visualization coverage, and let me know if you have any questions about this or other lessons.